Okay, so good evening, everyone. My name is Eric. We're on week 11, day 2. Yesterday for day 1, you guys went over Git and GitHub Actions fundamentals. Today we're going to take it further by integrating Ollama into your GitHub Actions workflow. And Ollama is a tool that uh, lets you run large language models into locally on your machine instead of calling a API or OpenAI or Bedrock. So you're able to do AI tests within your local machine. So let's get started. GitHub Actions automates code workflows in the cloud. Ollama is a tool for running large language models locally without requiring external API services. Together, they create intelligent automation systems that can analyze, reason, and respond to different situations automatically when code changes occur. This combination enables AI-powered DevOps pipelines while maintaining data privacy, cost control, and reliability. What are we trying to accomplish today? We aim to provide hands-on experience integrating AI models into automated workflows using GitHub Actions and Ollama. By the end of this module, participants will understand how to run AI models in cloud environments without external dependencies, automate intelligent processing workflows triggered by code events, and implement production-level optimization strategies for AI-powered automation. This skill set is increasingly valuable in the job market and represents the differentiator between basic DevOps engineers and senior-level positions. So we have one lesson, one lab, and one challenge today, as usual. We have our TLOs and ELOs down below. And for our challenge, I'll get into the challenge later on after we go through our lesson and lab. I'll show you guys what you have to do and the requirements that uh, you guys should have for your deliverables. So if if there's no questions, then we'll go ahead and get started with the lesson. Are there any questions? Let's go ahead and get started. So Ollama and GitHub Actions fundamentals. GitHub Actions automates code workflows in the cloud. Today we're integrating it with Ollama to run AI models automatically when code changes. This combination creates intelligent automation, so systems that don't just follow predetermined steps, but can analyze, reason, and respond to different situations. By the end of today, you'll understand how major tech companies build AI-powered DevOps pipelines and why this skill set is increasingly valuable in the job market. I need to fix that. We're moving beyond manual processes into automated intelligence. Every major technology company uses some form of automated workflow system, and AI integration is rapidly becoming the differentiator between DevOps engineer positions and senior level positions. So our focus areas, learning how to set up and run Ollama, which we will be going through the lab, running AI models in cloud environments without external dependencies, connecting code events to intelligent processing workflows. So Ollama can do things like analyze your files within your repo and perhaps provide suggestions, which is what you will be doing for the challenge. So again, what is Ollama? It's a tool for running large language models locally. It handles model downloading, loading, and inference through a simple command line interface. Unlike the cloud-based AI services, Ollama runs models entirely on the machine where it's installed. So the way it connects to GitHub Actions, so if you can in your workflows, you can have it install Ollama and practically send prompts to the large language model, which then it will give you some responses that you can work with. So that's how we will be using it today. Ollama manages the complex details of model quantization, memory allocation, and inference optimization automatically. You can interact with it through simple command lines like Ollama run Llama 3.2. So this will be the model that you are using, and then you're just gonna put your prompt in over here. What are the features of Ollama? Cost control, data privacy and reliability, and customization. So cost control, no per request charges, predictable infrastructure costs. Unlike cloud-based AI services that charge per API call, Ollama runs entirely on your infrastructure with fixed costs. Data privacy, sensitive code or data never leaves your environment. Many companies can't send proprietary code to external AI services due to security policies. Ollama enables AI-powered automation while maintaining data sovereignty. Reliability, no external service downtime or rate limiting. Your AI capabilities remain available regardless of external provider status. And then you have customization. You can fine-tune models for specific use cases and optimize them for your particular workflows and requirements. So how does Ollama work in cloud environments? When Ollama runs in GitHub Actions, it downloads models to the runner's local storage, loads them into memory, then processes your prompts locally on that virtual machine. The entire process happens within GitHub's infrastructure. So an example would be a developer pushes code to a GitHub repository, and the GitHub Actions workflow automatically installs Ollama, downloads a model, and runs the AI-powered code analysis, all without any external API calls to AWS or any other services, and prevents data leaving GitHub's infrastructure. The inference process is CPU intensive, but runs reasonably quick on GitHub's standard runners. A simple prompt might take 10 to 30 seconds to process, depending on model size and prompt complexity. After processing, you can capture the AI's response as text output, save it to files, or pass it to subsequent workflow steps. This creates possibilities for automated code review, document generation, or intelligent error analysis. Why Ollama in professional environments? There are benefits, no API costs, data sovereignty, zero rate limiting, offline capability, and predictable performance. So for no API costs, explanation would be it eliminates per request charges from cloud AI providers. An example of that would be a company runs 10,000 AI-powered code reviews monthly without any API fees, saving thousands in operational costs. Data sovereignty, proprietary code and sensitive data never leave your infrastructure. Example would be a financial services company uses AI for code analysis while maintaining compliance with data residency requirements. Zero rate limiting, explanation, no throttling or usage caps from external providers. So during a major release, the team runs hundreds of AI analysis simultaneously without hitting rate limits. Offline capability works without internet connectivity to external AI services since it's being ran locally. An example would be development continues uninterrupted during external service outages or in air-gapped environments. The last benefit is predictable performance. There's consistent response times without dependency on external service load. An example would be AI-powered workflows complete in predictable timeframes regardless of external provider status. So for our local setup, we will be using Ollama in a GitHub Actions environment. It's handy to know how it generally works first, so we'll install it locally. So to install Ollama on Mac OS, you would run this command if you're using Homebrew. Let me go ahead and move this screen. So I already have Ollama installed, but you guys can go ahead and where it is. I already have Ollama installed, so you guys just run these commands. I'll just go ahead and do it too. So brew install Ollama. It just looks like it's gonna update it. to the latest version. And then just follow the steps to install it. You should run Ollama version, and it should give you the version that you are running. So it should be 12.5. Do you guys have Ollama installed already? Does anybody not have it installed? Okay. So yeah, just verify that it's installed. Let's go take a look at the models available with Ollama list. I have this model right here, Ollama 3.2. And then let's check if Ollama, the Ollama service is responding by running this command, Ollama PS. Yes, okay. So you can run commands by you can run Ollama by a variety of different commands. Ollama run, Ollama pull, Ollama list, PS, stop, R remove for RM, show, and inversion. So for Ollama run, it just runs a model with an optional prompt. Let's go ahead and run it. Let's run Ollama run, and then specify the model that you will be using. Ollama 3.2. Where was it? Let's just copy and paste that. And then after you specify the model you will be using, you throw in the prompt that you want. So we'll say explain DevOps. See why we are getting this error. Probably has something to do with when we ran that Ollama PS. There's nothing underneath. Let's just check in with Chat GPT real quick. We can throw in a prompt that says, why am I getting an error? And then just put the error right underneath. Let's try repulling it because it did get updated over here. See, it looks like from 12.5 to 13.5. But when we ran the version, it says 12.5. So we got to figure out what's going on with that. Let's just try to rerun this again.
It mentions up there restarting Ollama after an update. Yeah, right where your mouse was. Brew services restart Ollama, like 6 lines down from where you are.
Oh, okay, okay. Nice catch, Nick. All right, let's check the version again. Okay, yep. Now it's running. So let's retry that prompt. So now it is working. And it'll just give you that response. So I'm just going to force stop it. I don't know how long the response is going to be, but you should be getting something back. And to force stop something within the terminal, you just hit Control C if you're on Mac. Let's try Ollama PS again to see what models are currently running. All right, so now we actually have it returning something. We can stop a model from running by entering Ollama stop. 3.2, 1 Bravo. Let's do Ollama PS again. Now nothing is running. And then let's show our models again by doing Ollama list. So we have that one model. We can actually remove it by doing Ollama RM and then the model. We do list again, it's not there. So now let's re-pull it by doing Ollama pull and then the model that you want. All right, so it's done. So if we run Ollama list again, we should see it. So interactive versus command line usage, we have interactive mode and command line mode. Interactive mode starts a chat session with Ollama run, and you can type prompts conversationally, kind of like a chat bot, and then you can just type exit to end the session. Command line mode is what we just did by doing Ollama run, specifying the model, and then our prompt. And this is how GitHub Actions workflows interact with Ollama. So let's just try doing Ollama run real quick with the model. So we can go into that shell. And here we are. So if you want to exit out of it, just type in exit. I think it's because I put that parentheses. You can also exit by doing Control D. An example would be for automation purposes, command line queries are essential. When a GitHub Actions workflow runs Ollama run and then the model plus the prompt, it captures the AI's response as text output that can be saved to files or passed to subsequent workflow steps. So we already interacted with Ollama. And then we can actually save those responses by doing a Ollama run, model, prompt, and then uh, the greater than symbol, and then specifying a text file. So let's see if what we get with this. Doing ls. It's still loading, so just give it a minute. All right, as you can see, the text file got generated. Let's go ahead and cat it. And we got our response back. We can also test the model performance with a timed query. So that's checking to see how long it takes. So let's go ahead and run that. And it just gives us some data back. For local development insights, before moving to cloud automation, reflect on your local experience. So model loading, memory usage, storage requirement, response times. That command that we just ran is one way to do it, to check everything. So model loading, notice the initial delay when first querying a model. The model must be loaded into memory before processing can begin. Memory usage, large models consume significant RAM while active. The 1B model requires approximately 1 through 2 gigabytes of RAM during inference. Storage requirements, each model requires substantial disk space. Plan your model selection based on available storage in your target environment. Response times, subsequent queries are much faster due to model caching. This observation informs our caching strategies for cloud workflows. These observations will inform our cloud optimization strategies. Local development gives you intuitive understanding of the performance characteristics we'll need to manage in automated environments. So in today's lab, you'll complete a GitHub Actions workflow that installs and configures Ollama in a cloud environment, downloads a large language model automatically, processes a prompt and captures the AI's response, and implements caching for production level performance. Any questions before we get started with the lab? All right, let's go ahead. Let me move the screen so we can see my terminal. All right, so first thing we're going to want to do is set up our project. So for that, we're just going to make a directory called Ollama Actions Week Modular. And this directory slash project that we are creating right now, you're going to be utilizing it for the rest of the week and just building more features on top of it. So keep that in mind as well. So let's go ahead and cd into that new directory we just created. We will initialize git. And then we will go ahead and create our GitHub's workflows directory. So we'll just run make directory -p. This flag stands for parental, so it just creates all the uh, parent directories. Because if you weren't running that, if you didn't add that p flag, it would just try to create the workflows directory within the .github, but there's no .github right now, so it'll give you an error. We can actually demonstrate that. So it's saying there's no .github directory. if we run the .p or -p, it's going to create the .github directory, then the workflow. So let's do an ls-a. And also, so if you add a period in front of a directory or a file, it will hide it. So that's why we did a ls-a. So if you just do an ls, you're not going to be able to see anything. So this directory got created when we initialized the GitHub, and then we just created this. So within our workflows directory, we're going to want to create a YAML file called Ollama basic. So let's do touch.github /workflows /Ollama basic. And let's just verify that it got created. It did, so we're good to go. We're also going to create a README file. And create a .ignore file. And again, we can't see it with the ls because we didn't include that -a. So here it is. We're going to want to add add some content to the .gitignore file. So within the file, we want to add we want to say don't push up anything that ends with a .bin, any of our Ollama models, and then OS generated files or any files created by our IDEs. Let's just do a cat.gitignore to see that it got added. Next thing we want to do is add content to our README file. And it's just saying this repository demonstrates AI-powered automation using GitHub Actions on Ollama and our capabilities. So we're going to do a cat README just to verify, and it got added. So let's go ahead and create our first commit and push it up to GitHub. So we'll do a git add just to stage everything. We can verify that by running git status. And then we will commit it. And let's go ahead and create our repo on GitHub by running this command. So this command is specifying to create the repo named Ollama Actions Week Modular. We want it as private. And then it just has our description for the repo. So our repo got created, and it'll give us a link. We can verify that. There's nothing pushed up yet, so that's why you see the screen. So setup is not done yet. We want our local repo to point to that new repo we just created. So we're going to run the git remote add origin. And you can really name it whatever, but this is uh, standard practice for the name of the repo that it's connected to. Just do a git remote add origin, and then you specify the link. So you can verify that by doing git remote dash v, and v just says view all. So whenever you push now on this directory, it's going to go to that repo that you just created on GitHub, and whenever you pull, it will be the same. So if you change the origin to something like, I don't know, repo, it'll say repo over here. It kind of just specifies where you want to push it to whenever you're running things, uh, running a command like git push, and then afterwards you'll specify the URL that you want to push it to. So you can do a git push origin. Let's go ahead and do a git push to our main branch. And now, since we pushed it up, if we refresh on our browser, uh, everything should be here that we just created within our local directory. We can do a GitHub repo view just to verify that the repo exists. And as you can see, this is what's shown within our README file. So we're good to go. It also shows the link to it. So let's go ahead and start uh, editing our YAML file. You can do it in VS Code, but I'll show you guys how to do it through the text editor, Vim. So you just run Vim and then specify the file that you want to edit afterwards. Press enter. You'll enter the screen. Press I to insert, and then just start adding your content. So first thing we want to do is specify the name of this workflow. It is Ollama AI processing. We'll press enter to go to the next line. We're going to specify our trigger events. So we're saying on push, whenever we push up from our local directory to the remote directory and onto the main branch, we want to trigger this workflow. This part right here, workflow dispatch, just specifies that you can run this workflow manually through the browser. Next thing we want to add is the job definition. So I messed up here by pasting the previous section. So one way to get rid of that is by pressing escape, and then you can actually delete it line by line by pressing D twice. And then go back into insert and just go ahead and paste the correct section. So this jobs section just specifies our jobs that we want to run within this workflow. We're running a job named AI processing, and it runs on Ubuntu. Next thing we want to do is add the steps that happen within this job. So our first step has the name of checkout code. And then this just points it to the correct directory and environment that everything will be running to. our next step would be the system information. So we're specifying we want to list out all of our important information like what OS we're running, available disk space, available memory, and CPU information. After that step, we want to install Ollama. So it's saying run this command and it will install it. Next step is to actually start the Ollama service. So it runs Ollama serve and sleep 10. So the ensign, if you guys remember from our CLI lecture, it just runs the first command in the background. And then the sleep 10 gives the service time to initialize before any following commands run. So it's pretty much just saying wait 10 seconds and then continue on with the next commands. We want to verify that it got installed. So we're running Ollama version and Ollama list. Are you guys kind of seeing a pattern here? You just have your job and then you specify the steps that you want within that job. So after we download and install Ollama, we want to actually download our AI model. So for that, we're just running Ollama pull and then the specific model. Before that happens, we just want to print on the text that says downloading the model so we can keep track of what's going on. And then after that step, we're just verifying that the model got downloaded with Ollama list. Next thing we want to do is execute an AI query. So actually run a prompt through Ollama. We're printing out a statement, and then we're setting a variable called response. And within there, we're just running our query. So Ollama run model, and then our prompt. We print out a statement and then print out the actual response that we get back. Our following step is actually the analysis. So we are making a directory called outputs and then specifying a variable called workflow file that points to our YAML file, to this specific workflow file, specifying a prompt variable, and then specifying another variable that just lists out uh, the YAML file. After that, we print out another statement, and then we make another variable called response, and it's the response that we're getting back from that run. So we print out a statement, AI analysis, and then we also print out that response, which gets saved to a file called within the outputs directory that we created with this name. So this file, whenever a workflow runs, everything that gets created is just within that specific environment or that specific run. So what we actually want to do is store it and upload it. So we'll create another step to actually save the response. So we create a variable timestamp and then uh, save our response into this file within our outputs and print out the statement as well as the output of that query. After we have saved everything, we want to upload it, and it gets uploaded to GitHub's Actions in something called artifacts. So all those files that we will possibly use or need to use will be accessible. So this specifies what to use to actually run uh, these commands. If always specifies to even if the previous job or the previous step actually fails, you still want to proceed with this step right here. We're specifying our path, so we're specifying the path to outputs, and then our retention policy, so 30 days. So that's what we will be that's all we that's all what this is what we're going to be having within our YAML file. So let's go ahead and write and quit by doing :WQ. This is a open file for writing.
So just a permissions issue?
Yeah, I'm thinking so. Let's copy and paste it. Oh my God. All right, hold on. Let's see real quick. I must have had a typo earlier. Maybe I did workflows instead of workflow. Let's actually rename this. So this command here is saying move this directory to the same directory, but name it as workflows. All right, gonna have to re-put everything in.
I put mine in the chat, so you could probably copy and paste it.
Okay.
Only one
Actually,
difference is that
actually,
my branch is named master, not main.
okay. Actually, yeah, I'm just gonna copy and paste
Okay.
the because of the formatting. So steps, check out code. Sorry about that, guys. All right. Yeah, so the reason why it wasn't allowing me to write and quit was because when I ran that command earlier, I had it as workflows and it couldn't find that specific directory or that specific file. So let's go ahead and add it. You could either do a period or actually specify the file that you want. So within this directory, you want this file, and then we're just going to commit it. And then push it up. So let's verify it in the browser. And we see workflow running. Let's go to the Actions tab. Let's go ahead and, so we have Ollama AI processing, which is the name that we gave the file right here. And then if we click on it and go to the jobs right here, we can see everything that's happening behind the scenes.
Eric, can you share your screen?
It stops sharing.
I can see it.
My bad. Yes, I can see it. Thank you.
So the yellow dot usually means that it's processing. If it's red, of course, you get an error and it stopped. Green, it was successful. Or these check marks. And usually installing Ollama takes a little bit, so just have to wait for that. Are there any questions while we wait? I know I was going through that fast.
Eric, how did you get to that screen where you could see all the steps and the status?
Yeah, so when you're in the main page, just go up to this
Actions, yeah.
navigation tab, Actions,
Mhm.
and then you can either click over here, this all your workflows. But for if you have different workflow files and with different names, they'll all populate right here, and you can actually specify which one you want to take a look at. So since this one is running, let's just go ahead and click it right here. And then this is the summary page of all the runs that's happened within that specific workflow. And then you can click over here within the job.
Yeah. Awesome. Thank you.
Yep. So as you guys can see, we have our everything that we put into that workflow file is running. For example, we're listing out all the available models that we have, and we downloaded this model, so that's why this is popping up. And then we also wanted to see our prompt or our response and end prompt, so it gets listed out over here. So it's running every single thing that we put into our workflow file. And everything is successful. You see that green arrow, so you're good to go. If we go back to that summary page, we can actually see that the artifact got uploaded. So we can actually download it by clicking on it. I've been getting an error on my browser for some reason, even though I have like 30 gigabytes of free space left. So I'll also show you guys how to run it on the terminal. So for that, you would just do you would run this command, gh run download, provide the tag name, and then just specify the name of the artifact that you want to download. And specify the directory. Actually, we don't want to run it in our workflows directory, so let's back up a little bit. A short key to go to the beginning of the line is Control A on Mac, and then you can delete everything by Control K. So let's save it to our main project directory and rerun that command. So GitHub run download, specify the name. AI responses 1. After you specify which one you want to download, you throw in the directory flag, and then actually specify where you want to save it. I want to save it in this current directory, so I include the dot. If we do an ls, we can see our artifacts. So notice that we have two txt files. This artifact is pretty kind of like a holder. So it will be a zip file when you download it, and everything gets stored within there. So let's do a cat to see what we got back from each of those files. And then let's look at the other one. So for the last file that we ran, it's just returning us what DevOps is. And then the first one just analyzes our workflow and suggests improvement. Are there any questions on what we just went through? What you've built, you created a GitHub Actions workflow that installs Ollama, downloads and configures AI, the model, executes intelligent prompts, and captures the responses, which you also save. So you demonstrate enterprise level AI DevOps automation patterns. So that's the end of our lab. Our challenge today will build up on top of that. So let's go over the requirements real quick. I want you guys to only use the CLI for this, but if it does get too complicated, you can use VS Code. The main reason why I wanted you guys to only use CLI was to try and limit your cursor usage. What uh, what we want to get what outputs we want to get out of this is different workflows. So let's go to actions. Should come out with you can really set this up however you want. I created two workflow files. So one for pull request review and then one just for testing on different OSs. So if we click on the AI pull request review, you should have different steps within that job. You set up analysis and report. You should get an output of an analysis, and it kind of uh, rates your workflows. You should get an artifact. Same thing with the AI matrix testing. You should get some artifacts. And most importantly, on your pull requests, you should have an automation to review your documents and your workflow, and AI can help you improve it. Your the AI model might hallucinate, so it'll probably give you something that doesn't make sense, but that's because we're using one of the lighter models. So you kind of just have to mess around with the model or prompt. But for today's uh, lesson, just as long as you get something over here, you're good to go. Any questions?
Just jumping on that a little bit, Eric. I don't think it's necessary for completing the exercise today, but just how we'll come to evaluate these models down the road, because there are probably more options when we're picking which models to use.
Mhm.
And those are some pretty serious outcomes, right? Hallucination. And
Yeah.
so, you know, I don't know if you've done any work in, like evaluating and picking the right model for the right, fit for the right task. Um, or if we're going to cover that future down the pike in this course.
Uh, Mainly the problem is with the hallucination is it's returning a response where it's saying there might be some security issues. That's why the model doesn't want to uh, return something back. And as you can see right here, I can guide you through a review of common workflow files focusing on best practices and security. But please note that uh, they'll be reviewing generic files without specific information. Or actually, which one? This is not the one I was looking at. So I did run multiple pull requests. It does give different responses. This the one I was referring to. I can't assist with reviewing or evaluating specific workflow files, especially if they contain sensitive information. However, I can provide general guidance on best practices and security considerations for workflow files. So a lot of AI is just messing around with the prompts. You could possibly get it to you could get it to review your file as well with good prompt engineering, which we will also be getting into later on. But yeah, for today's lesson, as long as you're able to set up the workflow, you can build on it and improve your system.
Yeah. Okay. I guess one follow-on question would be, we're putting a free model in. Are
Mhm.
you aware of, Git actions that could use an external service? Is that something you would just write into your Git action workflow? So, say you didn't want to install Ollama, but you wanted to hit your company's ChatGPT account or other paid for service. You could probably just build that in, and external calls are possible within GitHub Actions. Do you know?
Yeah. So you can
Okay.
pretty much yeah, you can run API calls to other
Yeah.
services. So yeah, that's possible.
Cool. Thanks.
Yep. Any more questions? All right. Yeah, so here's the challenge for today. Uh, I recommend working together and figuring this out. And again, try to limit your uh, uh, UI use and try to run everything from the command line so you know what's happening. And once you get comfortable with it, then you can use VS Code and only really go to the browser when you're checking your workflows. You can also check your workflows on the command line by running a GitHub run view. So we only have one workflow. If you have more, you can use the up and down arrow to check it out. Press enter, and it just shows you information. Press Q to quit. Any questions? All right. That ends it for you guys today's lesson. Just reach out if you guys run into any issues or are stuck. I'm going to be uh, running through some presentations, so but I'll be around afterwards. Go ahead and take your 15-minute break. Just be back by 7, and we will get started.